Greetings, Panthers. Time for video number 2 in the topic of significant figures, and specifically we're going to talk about how to use them now. The last video we learned how to count the number of significant figures, how to figure out how many significant figures there were, and why you would use significant figures. This video we're going to learn how to use them in a calculation, which really is the important thing for chemistry. So again, this is chapter 1.7 intro, and the section heading is significant figures and calculations. And the way to break this down, the way to think about this is there are different rules depending on what kind of calculations you're doing. So if you are doing multiplication and division, there's one set of rules. Addition and subtraction, there's another set of rules. And then we're also going to answer the question is, what happens if you have multiple steps? In other words, if you have a mixture of addition, subtraction, and multiplication and division in the same problem. So I'm going to just do a couple of different examples to give you a flavor for how you deal with this. So we're going to start with multiplication and division. And there's a reason for doing this. And really the main reason is this is by far the most common type of calculation you'll have to do in general chemistry. Most of our calculations are multiplication division problems. So if you understand the rules for multiplication division, then you're going to be able to get the significant figures correct on a whole lot of your problems. So here's the rule. Multiplication division, you count each number that you're multiplying or dividing. And when I say count the sig figs of each number that you're multiplying and dividing by. That's step one. And step two is whatever is the least number of significant figures in the calculation, that's what the answer is. So in other words, if 2 is the least number of significant figures in your calculation, your final answer can only have 2 significant figures. So I'm going to take an example of traveling. Suppose you're going to Europe and you have US dollars, and we're going to just make up a number here. We're going to say it's $275.36. That's how much US currency you have. And we could also write this as 275.36 USD. Sometimes you see it written that way because these weird symbols out front are a little bit hard to deal with. All right, so 275.36 US dollars, and we want to look up the exchange rate, or we want to get an exchange rate for today, and today's exchange rate just happens to be 0.888226 euros. So we'll say EUR for every 1 US dollar. There's a bunch of websites you can look this up on. This was on xe.com. Today happens to be the 24th of June, and that's the exchange rate at the moment I looked it up. Probably by the time you watch this video, that's not going to be the exchange rate anymore. It changes all the time. Actually, even by the time I made this video, it's probably slightly different than this number. All right, so if I take 275.36, I multiply it by this exchange rate, and I've been trying to get you in the habit of crossing off units. So USD crosses USD, and that leaves me euros as my answer. So that is going to be equal to, and I'm going to write all the decimals that showed up on my calculator, 244.5819114 euros. Of course, this is a ridiculous number, right? First of all, you don't even have coins that go below this decimal place here. So all these numbers are completely useless. Second of all, with this calculation, all these numbers are completely useless. But this is what happens when you type a number into your calculator. You end up with this big, ridiculous number like this. And so none of these are significant digits. So the way we do this is we go back and we count each number. 1, 2, 3, 4, 5. So this guy has 5 sig figs. And this one here is 1, 2, 3, 4, 5, 6. This one has 6 sig figs. All right, so my rule up above is we count the number of significant figures, and then whatever the least one is, that's what my answer should have. So my answer should also have 5 significant figures, and we can count them from here. 1, 2, 3, 4, 5. So my answer should be 244.58 euros. That would be the exchange rate with the proper number of significant figures. All right, 5 sig figs on this number, 6 on this one. The answer can be no better than the least number of significant figures, so we have 5 significant figures on my answer. All right, there's one example. Let's take another one. So let's say we have 342.1 meters, and I want to find out how many micrometers that is. So I need a conversion factor, which would be meters would go on the bottom and micrometers would go on top. Now you have to remember your prefixes, and it turns out it's 10 to the minus 6 meters for every 1 micrometer. Remember my hint I gave you earlier. That 10 to the minus 6, which shows up in that table, that always goes on the base unit. Meters is the base unit, not micrometers. So the conversion factor goes on the base unit. So 10 to the minus 6 meters for every 1 micrometer. Get in the good habit of crossing off units. Meters cancels meters. And when I do this calculation, this comes out to 3,421,000,000 micrometers. The other habit I want you getting used to is always write the unit down after you do a calculation. Okay, so always write that unit that's left, which is micrometers in this case. Now, if your calculator was set to scientific notation, this would not be the number you would get. But if you have it set default to a fixed decimal, you'd get a crazy number like this. And our usual significant figure problems, we don't know which of these are significant. So we have to go back here and we have to count each factor and find out how many sig figs there are. So if this would be a good place to stop the video and you can do it yourself. I'll wait 1 second. So this is 1, 2, 3, 4. 4 significant figures on the first calculation. And is this 1 micrometer, 10 to the minus 6? This is one of those examples of an infinite number of significant figures, because the definition of a micrometer is 10 to the minus 6 meters. So this counts as infinity, this one counts as 4, so this number should only have 4 significant figures. So I am going to rewrite this. Now I'm going to write it in scientific notation. 3.421 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8 micrometers. And that's my number with the correct number of significant figures and expressed in scientific notation, so there's no question as to where the sig figs are, and also I have units associated with it. Again, this number has units, correct number of significant figures. Okay, that's 2 different examples that we've taken a look at. Let's take a look at another one. Now I'm going to look at how many gallons of gasoline I burn on an average driving to work. So I drive about 17,000 miles in every year, and my car gets about 19 miles for every 1 gallon of gas. I have a Toyota RAV4. It's a little better than that on the highway. It's a little worse than that in town. It might be 21 miles to the gallon, but let's just use this as an example. Okay, miles cancels miles, so I'm going to have gallons as my answer, and this number turns out to be 894.7368421 gallons. Again, most of these digits are not significant. By the way, I do not want you writing these down on a test. None of this counts. So now we got to go back to these numbers and we say, all right, what's the number of significant figures? Well, this one, because I put a decimal place here, this one has 2 significant figures. This is 1 gallon per 19 miles. And what that's telling me, since I put a decimal place here, is that my uncertainty is in this place. Could be 20, could be 21, could be 18, but it's like plus or minus, say, 3 miles per gallon. All right, so my uncertainty is really in this digit right here. 17,000 is a problem because I don't know where the uncertainty is. This is an ambiguous number. This is not really a good way to write this out. But we're going to say could be 16,000, could be 18,000, could be 19,000, could be 15,000. It's not in the ones place for sure. It's not in the tens place for sure. That's where the error is. So this would have been better to write it out in scientific notation, but I'm just going to say that's where my error is. So this one has 2 sig figs. This one also has 2 sig figs. So guess what? My answer needs to have 2 sig figs. All the multiplication division problems, your answer needs to have the same number of sig figs as your calculations. So that means 890 gallons is the correct notation. But once again, this is uncertain. This is not a great way to write this number, because do I mean this place or do I mean this place where I have my problem? So this is a number that would be better to be written in scientific notation. I would not take off for this on an exam, but it's really not the best way to write it. So a better way to write this is going to be 8.9 times 10 to the 2 gallons. All right, that's my preferred way that you write this number out. If you wrote this number down, I would not take any points off for significant figures. I might say ambiguous or something like that. I might write something on it, but I wouldn't take any points off. This way is preferred. If you wrote this number down, I would take points off because that is not the correct number of significant figures. All right, now what if we want to say, well, how much money am I spending every year on gasoline driving to work? So I can take that 8.9 times 10 to the 2 gallons and multiply it by the price of gas today is about $2.10 per 1 gallon. Again, you might be watching this at some point in the future and saying, it's really $4.73, or it might be $1.50, and you might say, wow, it's really expensive when you were doing this. Gallons cancels gallons, so all we have left is dollars, and this turns out to be 1878.94. I normally would not write all this down. I'm just trying to give you an example of what you're going to get when you type it into your calculator. You're going to get a big, ridiculous number like this. Okay? And none of these are significant digits because this is only good to the tens place. Because of the estimates I made here, I only know it's 890, 900, 870, 880. My error is in this decimal place. So all of these digits do not mean anything because I don't know exactly how many gallons I've used. So I need to round this number to, there's 3 significant figures right here. There's only 2 significant figures right here. This number needs to have 2 significant figures. So a better answer is going to be $1,900. And again, you might be saying to yourself, well, don't you have the exact same problem? Yes, we do have the exact same problem. So a better way to write this would be 1.9 times 10 to the 3 US dollars. That gives me 2 significant figures. So $1,900 is how much I'm spending on average in gas. Now, this brings up a point which I have not had in any of these other problems, and that is rounding. So when we count this to 3 significant figures, or 2 significant figures, we need to go to the third figure, 1, 2, 3. We need to go to the third decimal, and we need to determine, do we need to round this number or not? And in this case, we have 0.7. So the 7 needs to be rounded up. 7 needs to be rounded up. So this should become 1,900 instead of 1,800. But in this case back here, 2 sig figs, this was a 4, so the 4 does not round up. So the way you do rounding is you take the digits that you have, the significant digits, and you go to the next place over and you say, do I need to round or not? The book gives a different set of rules. My rule is going to be if it's a 5 or greater, you should round up. 4 or less will round down. Okay, we'll just keep it simple. If this is a 5 or bigger, we're going to round it up. If it's a 4 or less, we're going to round it down. The other thing I'm going to do on multi-step calculations, I already mentioned this in an earlier video, I'm going to carry 1 or 2 extra digits through my calculation. So in this case, if I was doing, say, multiple calculations like this one down here, I'm going to drop all these, but I might carry the 10th place. I might say 894.7, and then I'm going to figure out at the end, I'm going to go back, all the way back and say, all right, 2 is what my final answer should be. And then I'm going to do the rounding. Okay, you can round after each step if you want to, or you can wait till the end and go back into each of your multi-steps and find the least sig figs and round there. Either way is fine. You may get a slightly different answer than I get, but that's really not going to matter that much. But the rule is, if it's a 5 or greater, we're going to round up. 4 or less, we're going to round back down. Okay, that deals with multiplication and division. What about addition and subtraction? All right, so for addition and subtraction, here's what the rule is for addition and subtraction. We take the least known decimal place, and that determines our sig figs. All right, what do I mean by that? I'm going to give you an example here. 35.1682 plus 0.0078, and I'm going to add 1.37 to this whole number. Okay, so I'm adding three numbers together, and you notice I have different numbers of digits after the decimal point. What I've done is I've lined all the decimal points up. I think this makes it easier to see where you have to do this. And then we're just going to add these guys up. There's a rule of thumb that a friend taught me a long time ago: never add in public, which I'm going to violate right now. So 0, carry the 1, 8, 9, 7 is 16, carry the 1, 6, 7, 7 is 14, carry the 1, 2, and 3 is 5.6, 36.5460. Okay, so here's how the addition subtraction rule works. We go through and we look and we see where is the last significant digit. So this one, the 2 is the last significant digit. The second one, the 8 is the last significant digit. This one, the 7 is the last significant digit. And the important point to note is this one is in the hundredths place. So whatever the least number of significant digits are, the least decimal places are, that's where my answer is going to have to be. Okay, so all of these guys beyond that decimal place are not going to count in my final sig fig calculation. So you want to go through and you want to identify which decimal or which placeholder is the last significant digit. And you could have 20 different things, but if one of these is in the hundredths place, and even though you got all these other things beyond there, that's where your answer is going to have to be. So now we need to take 36.5460, and I've got to look at rounding this decimal, and we're going to use the same rules, 5 and above. So this number should become 36.55. That's the correct number of sig figs on addition subtraction. All right, so the last thing we need to look at is what happens if there are multiple steps. So we will take another example, and I am going to do one like this: 35.86 times 16.1 plus 0.12. All right, so we've got a multiplication inside of a parentheses and then an addition next. You can go back to your probably middle school math, PEMDAS. And I want to point out that multiplication and division are equivalent to one another. There's not some special thing like multiplication is more important than division. These two are grouped together, and addition and subtraction are grouped together. What this stands for is parentheses, exponent, multiplication or division, addition or subtraction. Okay, so using this PEMDAS method, we want to do what's inside the parentheses first, and you notice that's a multiplication division. So we're going to do a multiplication division. We're going to use the rules of multiplication division to figure out the sig figs. We're going to set the sig figs, and then we're going to add and subtract. All right, so this number, it turns out, is, if we do that in multiplication division, that's 577.346. And here's where things differ a little bit. Before I add anything to this, before I do the addition step, which is the last step, I want to go back and fix the number of significant figures that are correct based on this first calculation I did. So this guy here, how many sig figs does that one have? That should have 4 sig figs, and this one should have 3. I've got 1, 2, 3, 4, 5, 6. I've got 6 sig figs here. So I need to get this back to a correct number of sig figs, which is only 3 sig figs. So now we have 577, and I'm going to add to that 0.12. So when I add these together, I have 577.12. But remember our rule? We need to find the placeholder that's the least. And in this case, it's the ones place. So even though I have this 0.12 adding to it, doesn't matter. My final answer is going to be 577. We could put a decimal point there, or we also could say 5.77 times 10 to the 2. Either one of those would be correct answers. Okay, so we have just gone through the rules of multiplication division. That is, whatever has the least number of sig figs, your answer has to have that same number of sig figs. Addition, subtraction, the rule is you look for the factor that has the least decimals, and wherever that decimal place is, that's what your final answer is going to be. In this case, it was the ones place. In this case, it was the hundredths place. And if we have multiple steps, we're going to use PEMDAS. We're going to, in this case, we do the calculation inside the brackets. Then you set the sig figs appropriate to whatever the calculation is you do inside the parentheses, and then you do your subsequent steps. If we had multiple brackets out here, say there's more steps, we would just do all the things within the parentheses first, set the sig figs correctly, and then calculate the answer from there.